about center of mass, even though it doesn't really fit in this chapter because it affects orbits and gravitation. So an object's center of mass is where we can consider all of the mass to be acting. So in this picture here, you guys have the notes as well. I'll attach them to Google Classroom. We see a diver that's just jumping up and going down. Any part of her, you would say, is following a parabolic path. Her center of mass is at her hips. So that part is also following a parabolic path. If something is not rotating, that's called translational motion. In the second part, she is both rotating and translating, moving both rotationally and in a straight line. And we can see that her center of mass is what follows the parabola. So she is only being affected by gravity. And the only part of her that's following parabolic path is the center of mass. Here's a wrench. If I were to balance a wrench, I could balance it at that point. So I can take all of the mass to be at that point. And when this crescent wrench is thrown across the screen, it looks like it is flying in an unusual pattern, but really if we follow the center of mass, it's just going in a straight line. All right, so how can we calculate this? The equation for center of mass is the mass times its position plus the next mass times its position plus the next mass times its position, plus ... divided by the sum of the masses on the bottom. So the bottom of the fraction is going to be the total mass. The distance is going to be the distance from this point here. All right, three objects are located along the x-axis as shown above. The center of mass of the object is at x equals. So I'm going to measure all of the distances from 0. I can pick whatever I want, but it makes the most sense because then when I get an answer, it's going to tell me how far from 0 I am, which is where I'm going to be on the number line. So I'm going to have m1, x1, plus m2, x2, plus m3, x3 over m1 plus m2 plus m3. So I'm going to have 3 times 0, because it's located at 0, 3 kilograms at 0, plus 5 kilograms at 3, plus 2 kilograms at 5 is equal to 3 plus 5 plus 2. And so this is going to be 15 plus 10 is 25 divided by 10. So 25 divided by 10 would be that the center of mass is at 2.5. So I could say that for this system, my thing's off a little bit, so it's not letting me mark right there, but for this system, the center of mass can all be concentrated there. All right, more complicated one. We have a wire that is bent. All the sides are equal, even though it doesn't look like it. It looks like it has a higher vertical length than horizontal length, but they're all capital L. The center of mass of a uniform wire bent in the shape shown above is located closest to which point? So I'm going to look at only the vertical distance. I know that I could balance it at that point because there's as much of the wire on this side as there is on that side. I'm going to consider the center of mass of each of the wires. And I think I should center this thing because I should have learned from the last one that it wasn't letting me mark the exact center, and that should be important. So I'm going to consider all of the mass of the wire to be located in the center of each of the segments. And I have 3 equal segments. So I'm going to say that I have mass here. And I'm going to say that this location is 0, comma, L over 2. I have mass here, and I'm going to say this location is L over 2, comma, 0. And I have mass here. And I'm going to say this location is L, comma, L over 2. Now, you can do this for X, Y, and Z. But really, I'm concerned with Y. I know that X, they're all Y on here, so I really don't need to calculate and find out that it's L over 2. So I'm going to do center of mass of Y. And so that's going to be M1, Y1 plus M2, Y2 plus M3, Y3 over the sum of the masses. So the first one is going to be a mass of, I'll say 1. They're all equal, so I can make it whatever I want. Anytime I get that choice, I make it 1, because that's an easy number to deal with. And it's located at L over 2. So that's my Y component. My second one also has a mass of 1, and its vertical location is 0. And the third one also has a mass of 1, and its Y component is L over 2. And then this is going to be divided by the sum of my masses, which I'm just going to say is 1 plus 1 plus 1, because they're equal wires. So I have L over 2 plus 0 plus L over 2 is going to be L. I have L divided by 3. So this is going to be my position. And looking at this, E is at 0, D is at 1/4 L, B is at 1/2 of L, C is my best one, because it's in the middle of those two. So 1/3 would be more than 1/4, but not quite 1/2. So C is the correct answer. All right, so here's one where I'd like to know where it is for both X and Y. I have ordered pairs. What is the center of mass of this system? I can do X, center of mass, and this is going to be M1, X1 plus M2, X2 plus M3, X3 over M1 plus M2 plus M3. So if this is my first one, I'm going to say it is 3 kilograms times 0.5 meters. If this is my second one, it is 4 kilograms times 2 meters. And if this is my third one, this one's going to be 3 kilograms times 3.5 meters. And then on the bottom, I'm going to have 3 kilograms plus 4 kilograms plus 3 kilograms. I'm going to use a calculator. So this is going to be 3 times 0.5 plus 4 times 2 plus 3 times 3.5 divided by 3 plus 4 plus 3. Gives me 2. So the X center of mass is located at 2. Now I'm going to do the Y center of mass. The Y center of mass is going to be M1, Y1 plus M2, Y2 plus M3, Y3 over M1 plus M2 plus M3. And if we had a third dimension, you could do the same thing. We do the same thing for C. So I'm going to say M1 was 3, so I have 3 kilograms, and it is located at 2.5 meters. I have 4 kilograms located at 0.5 meters. And then finally, I have 3 kilograms located at 2.5. And then that's going to be 3 plus 4 plus 3. So 3 times 2.5 plus 4 times 0.5 plus 3 times 2.5 divided by 3 plus 4 plus 3. 1.7. So I could say that the Y center of mass is at 1.7, or I could say the XY center of mass is at 2, 1.7.